So we can see that the difference in y now is 6 and the difference in x is 3. So the dimensions of this rectangle have changed. Welcome to episode 4 in the coordinate geometry series. So today we're going to be looking at parallel and perpendicular lines and how the gradients of lines that are parallel or perpendicular are related to each other. So as we discussed last time, if we look at the equation of a straight line, we were looking at how the value of m, or the coefficient of x, basically tells us how many times more y is increasing than x. So for example, if we have a value of m of 2, this means that y is increasing twice as much as x, right? Because y is equal to 2 times x. So for every 1 increase in x, we get an increase 2 times in y. Okay, similarly, if we have a value of m equals 5, well, for each increase in x, we're going to get 5 times the increase in y. We can also have a fractional value for m. For example, if m is equal to 1/2, then for each increase in x, y is increasing by 1/2. So now we're going to look at 2 separate lines and look at how their gradients relate to each other if they're parallel. So here we have 2 lines that are parallel. So let's start by just considering what the equations of these lines are. As we've previously discussed, we need 2 things to determine the equations of a straight line. The first is the gradient of the line, and the second is this value of c, which is always a constant, and this just tells us where the line intercepts the y-axis. So looking at this pink line here, we can see the pink line intercepts the y-axis as 0, so we're not even going to have a constant value, and then considering the m value, that would correspond to the gradient of this pink line. So we can see that as the pink line increases by 10 in the x direction, there's a corresponding increase of 5 in the y direction. So given that the gradient of any straight line is just given by the amount that the line increases in the y direction, for each increase in the x direction, we can just divide the increase in y by the increase in x. Okay, so in that case, we can divide 5 by 10 to give us 1/2. Okay, so that means the gradient of this pink line is 1/2, and the y-intercept, or the c value, is 0. So therefore, the equation of this pink line must be y equals 1/2 x. Okay, 1/2 corresponding to the gradient of 1/2, and there is no constant value because the y-intercept is 0. Now, these lines are parallel, so that already tells us what the coefficient of x will be for the equation of this green line. It's going to be the same as the coefficient of x for the pink line because the gradients must be equal. Okay, so that's the first important point, is that 2 parallel lines will have equal gradients. So that gives us our m value of 1/2. Now for the constant that we are going to add to this x term, well, we know that this corresponds to the y-intercept. So the y-intercept for this green line is 5 because it's crossing the y-axis at value 5. So the equation of the green line is given by y equals 1/2 x plus 5. So the equations have identical coefficients of x, whereas the constant values differ because the y-intercepts differ. Now, let's consider a new line that is perpendicular to these 2 lines here. Again, we want to think about how the gradient of a perpendicular line relates to the gradient of its perpendicular counterpart. So for this example, we want to know how the gradients of our green and pink lines, which is 1/2, will relate to the gradient of a line that is perpendicular. Now the best way to think about this is to think of a perpendicular line as a 90-degree rotation. Okay, so by definition, perpendicular implies that there is an angle of 90 degrees between the lines. So let's think about how that would affect the gradient of a line. Now we know that the gradient of a line is the increase in y per unit increase in x. Okay, so in other words, we're just dividing the difference in y by the difference in x. Okay, that's what we do when we calculate the gradient. It's just the ratio between the increase in y and the increase in x. So as we've already calculated, the gradient of this green line is 1/2. Okay, we can select any increment in x, and we'll always get an increment in y that is 1/2 of that increment in x. Okay, so in this case, we can say 3 divided by 6 is 1/2, and there you go, it gives us our half. Now, if we form a rectangle here, this is just going to help with visualizing how the gradient of a line changes if we rotate it by 90 degrees. So looking at this rectangle here, we can see that the green line forms the diagonal of this rectangle. Okay, now the length of the rectangle corresponds to the x increase, and the height of the rectangle corresponds to the y increase. Now let's see what happens if we rotate the line and therefore this rectangle. So what I've done here is I've just rotated the rectangle, and you can see that it actually fits onto this perpendicular line because the rectangle that we fit around the green line has now been rotated. So it makes sense that the rotated rectangle is going to fit around the blue line that is perpendicular. So we can see that the difference in y now is 6 and the difference in x is 3. So the dimensions of this rectangle have changed. And remember, the dimensions of the rectangle correspond to the difference in x and the difference in y, right? Difference in x, difference in y for the green line, and here we have the difference in x and the difference in y for the blue line. What does that mean? It means that the gradient, instead of being 3 divided by 6, it's going to be 6 divided by 3, because the dimensions, or the difference in x and the difference in y, it just flips the value. So the ratio of 1/2 here is just the gradient of the green and pink line. So we just invert that gradient, which will give us 2/1, or just 2, and that will be the gradient of a perpendicular line. It will be the reciprocal of its perpendicular counterpart. So that will give us 2 for the gradient, and for the constant value, we're just going to have 0, just as we had with the pink line, because the y-intercept of the blue line is indeed 0, giving us a straight line equation for the blue line of y equals 2x. Now, this isn't quite right. Now, the reason this isn't quite right is because something else happens when we rotate a line by 90 degrees. Now, going back, we said that the gradient of a straight line is the increase in y divided by the increase in x, and that when we rotate a line by 90 degrees, the increase in x becomes the increase in y, and the increase in y becomes the increase in x. Hence why the gradient of 1/2 for the green and pink lines becomes 2/1, or just 2 for its perpendicular counterpart, the blue line. Now let's just look at what's happening only to the increase in y as we increase in the x direction. So let's look at the green line first. As we increase by 6 in the x direction, there's an increase of 3 in the y direction. Whereas when we increase by 3 in the x direction, you can see that there's actually a decrease in y. So to correct that, we should really have -6. So as we increase in the x direction, the line is decreasing in the y direction. What does that mean? Well, it means that the value for the increase in y will actually be negative because it's actually a decrease in y as x increases. So they're of the opposite sign. Now, to quickly see this, we can see that the line is going down from left to right. So whenever a line is going down from left to right, this will always correspond to a negative gradient. So this is the second thing that happens to the gradient of a perpendicular line. Not only is it the reciprocal or the inverse, but it's the negative inverse. So this equation would therefore be y equals negative 2x. So when two lines are parallel, the gradient of the first line is equal to the gradient of the second line. This is far more intuitive. Whereas for perpendicular lines, we've just seen that the gradient is inverted because the increase in y and the increase in x swap places when we rotate a line by 90 degrees, and becomes negative because that increase in y suddenly becomes a decrease in y, giving a negative gradient. So the question is, how do we say that two values that are negative inverses of each other are related? How do we write that as a mathematical relation? We can say that m1, or the gradient of the first line, multiplied by the perpendicular gradient, or the negative inverse, is equal to negative 1. In other words, if two gradients correspond to two lines that are perpendicular, then their product, or the multiplication, will always equal 1. That is, if we take one value and multiply it by its negative inverse, as is the case for two perpendicular lines, we will always get negative 1. So just remember these two very important relations between gradients of parallel lines that are equal and gradients of perpendicular lines will always multiply to give negative 1. In other words, the gradient of the first line will be the negative inverse of its perpendicular counterpart. Join me in the next video where we'll be looking at how to calculate the midpoint of a line. That is the point that lies directly halfway between two given points. See you next time.